Hey everyone, welcome back to Think Tech. In today's podcast, we'll talk about deep learning, where we will explore the exciting world of artificial intelligence and machine learning. Deep learning is a subset of machine learning that uses neural networks to model and solve complex problems. This technology has revolutionized the field of artificial intelligence and is responsible for many recent breakthroughs we have seen in image and speech recognition, natural language processing, and even game playing. In this podcast, we'll deep dive into the theory and practice of deep learning. We'll explore the latest research, applications of this powerful technology, as well as the challenges that we face with deep learning. So, whether you are a seasoned data scientist or just curious about the potential of artificial intelligence, this podcast is for you. So, sit back, relax, and join us as we explore the cutting edge of deep learning and its impact on the world around us. So, before understanding what deep learning is, let us first understand what artificial intelligence is and what machine learning is. So, artificial intelligence (AI) is the field of study concerned with creating machines that can perform tasks that normally require human intelligence, such as perception, reasoning, and decision making. Machine learning is a subset of artificial intelligence that focuses on development of algorithms that can learn from and make predictions based on data without being explicitly programmed or without being explicitly told what to do in what scenarios. ML is used in a wide range of applications, including image recognition, natural language processing, and recommendation systems. ChatGPT is one of the recent examples of a very advanced natural language processing and conversational AI model that has been very famous in recent times. Now comes deep learning. So, what is deep learning and how it differs from traditional machine learning? Deep learning is a type of machine learning that uses artificial neural networks with multiple layers to learn and make predictions based on data. So, we'll discuss what neural networks are in detail, but deep learning makes use of very large neural network to learn and make predictions based on data. Traditional machine learning methods typically rely on feature engineering, where domain experts manually identify relevant features in the data and then feed those features to the model to make or help the model to make predictions. In deep learning, the neural network learns to identify and extract relevant features from the data on its own without any manual intervention, making it much more versatile, powerful, and capable of handling much more complex data, the correlations of which are not visible to even human experts. So we talked about how deep learning makes use of artificial neural network. So now let us understand what is a neural network and what are the components of a neural network. So if you want to understand basically what neural network is, let's go back to our childhood. I hope every one of us would have played with building blocks and tried to build a tower as tall as we can. Artificial neural networks are kind of like building towers, but with maths instead of blocks. Just like how you use different blocks to make different shapes, artificial neural networks use different parts called neurons to do different things. Each neuron takes some input like a number or a picture and then does some mathematical calculations to it. The result of the math is called the output of the neuron. Then the output of one neuron becomes the input of another neuron and the process repeats. It's like stacking blocks on top of each other to make a very tall tower. By doing this, the artificial neural network can learn to do things like recognizing pictures or even play complex games like chess or Go. And just like how you need to practice building towers to get better, artificial neural networks need to practice with a lot of examples to get better at their tasks. So if we have to define it more formally, artificial neural networks are computational models inspired by the structure and function of the human brain. They consist of interconnected nodes or artificial neurons that process and transmit information. The nodes are organized into layers with input and output layers and one or more hidden layers in between. And the weights between the nodes are learned through a process called backpropagation, which we'll discuss in detail, which adjusts the weight to minimize the error between the predicted output and the actual output. So now let us understand each of these components in a little bit more detail. So the very first component of artificial neural network is the input layer. This is the layer where the input data is fed into the network. It consists of nodes that represent the features of the input data. For example, if you're trying to classify images of cats and dogs, the input layer would represent the pixels of the image. Then comes the hidden layers. These are the layers between the input and the output layers. These consist of nodes that perform mathematical computations on the input data. Each node in the hidden layer is connected to every node in the previous and next layers. The more hidden layers there are, the more deep the network is said to be and more complex the computations it can perform. The next component in ANN is output layer. This is the final layer of the network where the output of the computation is generated. It consists of nodes that represent the output of the network, such as a classification label or a numerical value. In the case of cat versus dog example, the output layer would represent the probability of an image being a cat or being a dog. Another very component, something that we are discussing, is the activation function. This is the function that is applied to the output of each node in the hidden and output layers. It is basically used to introduce non-linearity into the network, allowing it to learn more complex patterns in the data. If there is no activation function, then no matter how deep a neural network is, it will not be able to understand complex patterns beyond a linear relationship between the data. Common activation functions used are sigmoid function, tanh function, and rectified linear unit, also known as ReLU. The fifth and the final component of ANN ANN network is the weight. So each connection between the nodes in the network has a weight associated with it. The weight determines how much influence the output of one node has on the input of another node. And during training, the weights are adjusted to minimize the difference between the predicted output and the actual output, also known as the error of the prediction. Now there is one more component which we can discuss as a separate component also, but generally that is included in the weight part itself, and this component is known as the bias. So each node in the network also has a bias value attached with it. The bias is an additional parameter that is added to the weighted sum of the inputs to the node. It allows the network to shift the activation function horizontally, giving it more flexibility in the patterns it can learn. So this is just a mathematically convenient way to shift our activation functions around the origin, and which allows to learn and normalize the data and learn more complex patterns. So together, these components allow an artificial neural network to learn from data, make predictions, and perform complex tasks like image recognition, speech recognition, and natural language processing. So we discussed that ANN uses backpropagation to learn and reduce the error in its prediction. So now let us talk about what backpropagation is. So if we have to understand fundamentally what the backpropagation means, let us understand it in this sense. Backpropagation is a way for computers to learn how to do something better. It's like when you learn how to draw a picture of a cat. At first, you might not draw it perfectly, but then someone tells you what you did wrong and helps you fix it. Backpropagation is kind of like that. When the computer makes a mistake, it goes back and looks at what it did wrong and then tries to fix it so it can do better next time. This happens over and over again until the computer gets really good at doing the thing it is supposed to do. So to understand it more formally, backpropagation is an algorithm used for training artificial neural network. When a neural network makes a prediction, it compares the prediction to the actual output and calculates an error. Backpropagation works by propagating this error backwards through the network, adjusting the weights along the way between the neurons at each layer based on their contribution to the error. The weights are adjusted in the opposite direction of the gradient of the error function with respect to the weights using a method called gradient descent, which we'll discuss in detail later. This process is repeated iteratively until the error is minimized and the network has learned to make accurate predictions. Backpropagation is a key component of deep learning, allowing neural networks to learn from large amounts of data and make predictions on relatively new unseen data. Now, gradient descent is a method to use to optimize the weights by iteratively adjusting them in the direction of the steepest descent of an error function. So what does that mean? Let us understand with the help of an example. Imagine you are at the top of a big hill and you want to go down to the bottom, but it's really foggy, so you cannot see which way to go. You start walking in a random direction, and after a few steps, you check if you're going up or down. If you're going up, you turn around and take a step in the opposite direction. If you're going down, you keep going in the same direction. You keep doing this over and over, taking small steps in the direction that makes you go down the fastest until you get to the bottom of the hill. Gradient descent is exactly like that, but with a maths problem instead of a hill. The goal is to find the lowest point of the maths problem. You can imagine a parabola. So the goal is to find the lowest point of a parabola. You start with a random guess and then you check whether you are going up or down. If you're going up, you change your guess to a little bit. If you're going down, you keep on going down. You keep doing this over and over again, taking small steps in the direction that makes you go down the fastest until you find the lowest point of the maths problem. So gradient descent is an optimization algorithm commonly used in machine learning to minimize a cost function. The goal of gradient descent is to find the set of parameters or weights that minimize the cost function by iteratively adjusting the parameters in the opposite direction of the gradient of the cost function with respect to the parameters. By repeating this process multiple times, we can find the weights that minimize the cost function and optimize our model. There are different variants of gradient descent such as stochastic gradient descent, mini batch gradient descent, and Adam optimization. We will not discuss each of these, but the fundamental principle of all these algorithms are pretty same to how gradient descent actually works. These variants just adjust the learning rate and the size of the batch of the data used in each iteration to improve the convergence rate and the stability of the algorithm. So now, having discussed about backpropagation and gradient descent, which helps the artificial neural networks to learn, let us talk about different types of neural networks and see which kind of neural network specializes in what problem that they solve. So let us first talk about convolutional neural networks, also known as CNN. CNNs are specialized neural networks designed for image recognition and processing. They use convolution layers to detect features in the image and pooling layers to reduce the dimensionality of the features. The next neural network that we'll talk about are RNNs or recurrent neural networks. Recurrent neural networks are designed for processing sequence data such as natural language processing and speech recognition. They use recurrent layers to model the temporal dependencies between the elements in the sequence. So ChatGPT also is a very advanced version of recurrent neural networks. The practical applications of deep learning include computer vision, natural language processing, speech recognition, autonomous vehicles, and many more. So as I said, ChatGPT is again a implementation of deep learning in the natural language processing field, and this has been very popular in the recent times because it has been able to solve problems in a multi-domain environment where users can interact with ChatGPT on almost all topics, and it is able to maintain a coherent conversation on all those topics. So the most important thing for deep learning to work or very big artificial neural networks to work is that they need to be fed a large amount of data. So deep learning models require a very large amount of data to learn the patterns and features in the data and to generalize to new data. So as we discussed, the main difference between deep learning and traditional machine learning methods is that in deep learning, there is no one that identifies the features of the input data and then tells the model to base its learning on those features. Rather, we just give it a big dump of data and we ask the model to process that data and find out hidden correlations in those datasets which generalize good enough so that if a new set of data or unseen data comes, the prediction accuracy of the model does not drop. So since we have reduced the major bulk of work that we used to do of feature engineering or identifying features, The amount of data that the model needs to seize has to be very huge as compared to traditional machine learning models. Also, we need to make sure that the distribution of the data is much more uniform and it covers all aspects of the problem that we are trying to solve, so that the models that we build are not biased or are not skewed to a particular use case of the problem that we are trying to build. So that is why the quality and the diversity of the training data can have a significant impact on the performance of the model. Now there are a lot of challenges as well that we see with deep learning. So let us go through each of these challenges and understand in detail how these challenges can impact the training and accuracy of a deep learning model. So the first problem that we see, or the first issue that we have with deep learning algorithms, is the data availability. Now, as we discussed, deep learning algorithms require large amount of data to learn patterns effectively. In many cases, obtaining large and high quality datasets can be very challenging, especially for specialized fields where there may not be so much data collection happening. So this is very common in healthcare industries, where collection of data is also based on how the individuals have responded to privacy surveys, as well as you cannot collect a very large amount of data because it is limited to the amount of people who are maybe suffering from that particular disease or who have agreed to share their data for use of training. So that is why availability of good quality data, good quality labeled data sets is very difficult to get in deep learning or for solving deep learning problems. The next problem or challenge we face with deep learning is computation power. Deep learning algorithms require a lot of computational power to train and optimize the neural network. The training process can be very time consuming, and the cost of hardware and cloud computing resources can be very, very expensive. So training deep learning algorithms is not environmental friendly. In fact, very recently a study was published that to answer 25 to 50 questions, ChatGPT almost requires 500 ml of water. So this is a very concerning point where we need to come up with more eco-friendly ways to train deep learning algorithms. Otherwise, with the advancement and building of much larger deep learning algorithms and deep learning models, we'll consume power that will have a detrimental effect on our environment and which will not be a sustainable way to continue growth of artificial intelligence algorithms. The next challenge that we face with deep learning is the problem of overfitting. So overfitting occurs when a model learns to perform well on the training data but fails to generalize the new and unseen data. This circles back to the problem that we discussed of having diverse and uniformly distributed data for training deep learning models. If we have collected a data that is skewed or biased toward a particular subset of the problem, then our model will overfit to that particular use case and will not be able to generalize to any unseen data or use cases that it has not seen before or it has not been trained on. There are a lot of techniques to prevent overfitting, but data diversity and good quality data is a must to start with. Apart from that, in deep learning, there are a lot of techniques like regularization and early stopping to prevent overfitting. The next challenge that we have with deep learning is the challenge of interpretability. Deep learning models can be very complex and very, very difficult to interpret. This can be a challenge in fields where transparency and accountability are important. It is difficult to understand how the model is making its prediction and identify the source of bias. So as we discussed that in deep learning, we do not give any features to the model to learn from. We just give it a dump of data and expect the model to identify hidden correlations in the dataset and come up with a generic model on which it can perform well even if it sees new data that it has not seen before. But how the model is able to come up with such correlations is something that we are not able to explain. And in scenarios where we need that sort of explainability by artificial intelligence algorithms, this can be a big challenge. A very common use case is the use of AI algorithms in criminal justice system. The models cannot just output the quantum of the punishment or quantum of the penalty that they think is suitable for a particular case. They also have to justify and explain the reason and the rationale behind how they have come to the certain conclusion. And this is something that is missing in present day algorithms, and is something that we should strive to build in all deep learning algorithms, so that we know whether the facts that have been taken into consideration to reach to a certain prediction is correct and does not suffer from any unintended bias. The next challenge that we face with deep learning is a hyperparameter tuning problem. Deep learning models have many hyperparameters such as the learning rate, the number of hidden layers, dropout percentage, and many more parameters that are there. And the tuning of these parameters can greatly impact the performance of your model depending on the problem that we are trying to solve. So tuning these hyperparameters are very important to come up with high accuracy models, but it requires expert knowledge to tune these parameters and also can be very time consuming. So training deep learning models is not a very easy task. You have to fine tune a lot of these parameters to a different extent, and that is only when you can come up with models that are highly accurate and able to perform well. The last problem that we see with deep learning is adversarial attacks. So since model is not being controlled by any human intervention, adversarial attacks are deliberate attempts to trick deep learning models by introducing subtle perturbations to the input data. These attacks can be difficult to defend against and can compromise the security of deep learning applications. Because if the data on which the model is being trained on itself is corrupt and does not represent the true nature of the problem that we are trying to solve, then the model who is learning from that data will not be able to correctly understand the actual nature of the problem it is able to solve, but will fall prey to these adversarial attacks and will inbuild the capacity to give incorrect answers on certain questions or in certain scenarios where it should not do so. So to defend against these attacks, I think a common approach that is used is of data cleansing and data review. So before feeding any data to artificial intelligence models, we need to review whether we are feeding it correct data and that data is free from any sort of bias or any sort of adversarial attempts to place malicious data while training of the deep learning models. So deep learning has a potential to transform society and revolutionize many industries, including healthcare, finance, transportation, and entertainment. So let us understand few of the impacts that deep learning has had on our existing society. So first of all, deep learning has improved healthcare because deep learning can help to analyze medical images, detect diseases, and identify potential treatments. It can also be used to develop personalized medicine based on patients' unique genetic profile. Another area where deep learning has been very helpful is in safety and security. Deep learning can be used to improve safety and securities in areas such as transportation, surveillance, and cybersecurity. For example, self-driving cars can use deep learning algorithms to detect and avoid obstacles on road, as well as deep learning can be used to detect and prevent cyber attacks. So again, this is something that because of the scale at which deep learning algorithms can operate, it makes it very easy for them to identify any anomalies, be it any transactional data or any cybersecurity incidents, where they can easily identify amongst millions of events an event which is abnormal and which should be reported, which is impossible for humans to catch by manual introspection. And finally, as we all know, deep learning has been used for personalized entertainment. Netflix, Amazon Prime, YouTube, everyone is using deep learning to make better recommendation systems so that they are able to recommend movies, music, books based on a person's preference and historical view activity. Now, there are some ethical concerns whether the use of deep learning to suggest or recommend these things to a person is valid or not. But if we look in the bright side, or if we look at the positive side, they have been able to build systems that are much more customized to everyone's personal needs, and you're able to find the content that you want very easily. To what extent is this ethical, and to what extent are the practices that are being done to build these systems are ethical, is a different question and is something that should be answered separately. So having said that, with great power comes great responsibility. The increase of deep learning and AI does raise important ethical concerns such as data privacy, algorithmic bias, perpetuation of systemic discrimination, and job displacement. It is important that we understand these concerns and develop regulations and guidelines to ensure that the benefits of deep learnings are realized in responsible and equitable manner. Looking to the future, the development of deep learning and AI models will continue to accelerate, and we can expect to see further breakthroughs and innovations in the field like GPT-4. However, it is important to remember that deep learning and AI are not a silver bullet for all of society's problems and should not be thought of as such. We must continue to approach the development and implementation of these technologies with high caution and always consider their potential impacts on society and world at large. I think this is a good point for us to conclude our discussion. I hope you found this interesting and educative. Thank you so much for listening. Please let me know in comments if you want me to make podcasts or any of these topics in more detail. Be sure to listen to all our future podcasts. As of now, this is Shivam signing off.